In this section, some of the examples are given. The first question is, the total cost of producing X units of a product is given as Q equal to 6X plus 200 and 80 units are produced. This is the question. That is, the total cost function is given as Q equal to 6X plus 200 and 80 units are produced. Then we need to find out the variable cost, fixed cost, total cost, variable cost per unit, average cost per unit. This cost needs to be derived from this function. Here the total cost of producing X unit is given as Q equal to 6X plus 200. In this, the variable cost is 6X. This is the fixed cost. 6X and total units produced is 80 units. Therefore, 6 into 80 equal to 480. This is the variable cost. In this cost function, the fixed cost is 200. Therefore, the answer to the second question, fixed cost equal to 200. Third question is find the total cost. Total cost is, the cost function is given, the cost of producing X unit is given, and the total units needs to be produced are also given. Therefore, total cost equal to this into 80 units. That is, X equal to 80. 6X plus 200 where X equal to 80. That is, 6 into 80 plus 200 equal to 680. Fourth question is variable cost per unit. Variable cost per unit is total variable cost divided by the units of total products or the units of the products. That is, variable cost is 480 and the total units to be produced are 80. That is, 480 divided by 80 equal to 6. This is the variable cost. And the next question is find the average cost per unit. Average cost is total cost divided by the units of the product. Total cost is this one and units of products is 8 units. That is 680 divided 680 divided by 80. That is 8.5. This is the, from this function, this is the total cost of producing X unit. Total units produced is 80. The given the given function, variable cost is 6X and fixed cost is 200. The total cost equal to 6 into 80 plus 200. Then the average cost, average variable cost, etc. can be derived as given this. Some of the homeworks are also given. Here, the total cost of producing X units of the products is given as 8X plus 400. If 50 units are produced, then find the variable cost, fixed cost, total cost, average variable cost like the earlier one. The second question is about Q equal to 100X plus 300 and 60 units to be produced. Find the variable cost, fixed cost, total cost and variable cost per unit and average cost per unit. Then second example is compute average cost for the total cost function given as the total cost function equal to 8x square plus 4x plus 2. The second example is compute average cost for the total cost function. Total cost function is given as TC equal to 8x square plus 4x plus 2. This is the total cost function. Then the average cost is, we know average cost equal to total cost divided by x. That is, this function divided by x, that is 8x square plus 4x plus 2 divided by x. That is 8x square by x equal to 8x, 4x by x equal to 4, 2 by x equal to 2 by x. Then second question is find the marginal cost for the total cost function. Marginal cost is the first derivative of the total cost. That is, find the first derivative or take the first derivative of total cost function. The total cost function is TC equal to 4x raised to 4 minus 3x cube minus 2x square plus 5x. And then marginal cost equal to dTc by dx, that is 16 4 into 4x square, differential of 4x square, x raised to 4 is 4 into 4 x raised to 4 minus 3, that is 16 x raised to 3, that is minus 3 into 3 x raised to 3 minus 1, that is 9x raised to 2 minus 4. 2 into 2 x raised to 2 minus 1 is 4x plus 5x. Differential of 5x is 5. This is the marginal cost function. Likewise, find the average cost and marginal cost of these functions. The next example is the average cost function is 20q plus 10 plus 5q. What is the marginal cost at q equal to 2? Here the average question is the average cost is given. Average cost is 20 divided by q plus 10 plus 5q. Then from this average cost we can find the total cost. Then only we can find the marginal cost. That is total cost equal to average cost into the number of units produced, AC into Q. That is, multiply this average cost into Q. That is 20 divided by Q plus 10 plus 5Q, the whole into Q. That is 20Q into Q is 20, 5Q 10 into Q is 10Q, 5Q into Q is Q square. This is the total cost function. And take the first differential of this function, that is a differential of d by dq of 20 10 plus 10q plus 5q square. Differential of 20 is 0, differential of 10q is 10 plus differential of 5q square is 10q. At q equal to 2, the second part is at q equal to 2, marginal cost equal to, substitute q equal to 2 into the marginal cost function, that is 10 plus 10 into 2, that is 30. Then another example is given as, given the total cost function c equal to 1 by 3 q cube minus 3q square plus 9q, find q when the average cost is minimum. Find also the marginal cost at the level of q. Here we want to find out the output when average cost is minimum. Then the total cost function is given as c equal to 1 by 3 q cube minus 3q square plus 9q. This is the total cost. Therefore, the first step is find the average cost and find the minimum of average cost. And the conditions for minimum are given as the first order condition should be equal to 0 and the second order condition greater than 0. This is the condition for the minimum. Then find the value of q. Then find the marginal cost at this level of output of the q. Therefore, given Tc equal to 1 by 3 q cube minus 3q square plus 9x, average cost equal to Tc by q. That is, divide this whole equation, average cost by q. That is 1 by 3 q cube by q is 1 by 3q square minus 3q square by q is 3q plus 9q by q is 9. This is the average cost. Then this is the average cost. Second part is find the minimum of average cost. Therefore, we need to take the first order condition equated to 0, derive the second order condition and see whether it is greater than 0 or not. First order condition of this average cost function is differential of take the differential of this function, that is d by dq of 1 by 3q square minus 3q plus 9. That is 1 by 3 into 2 into q 2 minus 1. This is the differential of this 1 by 3 q square. That is 2 by 3 2 minus 1, q raised to 2 minus 1 is 1. Therefore 2 by 3 into q minus differential of 3q is 3. That is 2 by 3q minus 3 equal to 0. From this we can find out the q. That is 2 by 3q equal to 3. Therefore q equal to 3 into, take this to the right hand side, 3 by 2. That is 9 by 2. Q equal to 9 by 2 is 4.5. Q equal to 4.5. And we want to see whether this output is produced at the minimum of AC. For that, we need to take the second order condition. The second derivative of AC for minimum is the AC function. This is the first order condition. Take the differential of this. Again, that is the second. That is d by dq of AC dash or d by dq of 2 by 3q minus 3 equal to, that is differential of 2 by 3q is 2 by 3 into 1, the exponent of q is q raised to 1. 2 by 3 into 1 into q, 1 minus 1, that is q raised to 0. Then the differential of 2 by 3q equal to 2 by 3. And the differential of 3 is 0. Therefore, d by dq of AC dash equal to 2 by 3. 2 by 3 is greater than 0. Therefore, AC is minimum. Both conditions are satisfied. The first order condition equal to 0 is satisfied and the second order condition greater than 0 is satisfied. Thus, AC is minimum at Q equal to 4.5. We can conclude that AC is minimum when the firm produces Q equal to 4.5. And then the third part is find the marginal cost. That is, marginal cost is the first order derivative of the total cost function, that is dTc by dq, that is d by dq of the total cost function. Total cost function is 1 by 3 q cube minus 3q square plus 9q, that is equal to 1 by 3 q cube is 1 by 3 into 3 q raised to 3 minus 1, that is 1 by 3 into 3 is 1, 3 and 3 cancels 1, q raised to 3 minus 1 is 2, that is q square minus 3q square, differential of q 3q square is 6q, and plus the differential of 9q is 9, and find the marginal cost at q equal to 4. This is the output when AC is minimum, and value of marginal cost when q equal to 4.5 is given as substitute q equal to 4.5 into the marginal cost function. Then we will get 2.25. When AC is minimum, Q equal to 4.5. When MC when Q is 4.5 equal to 2.25. This is the good. This is the solution to this question. That is, given the total cost function 1 by 3 q cube minus 3q square plus 9q, find average cost. When the average cost is minimum, find the marginal cost at the level of Q. Therefore, first derive the AC, then see whether it is minimum, the first order condition equal to 0, find the Q, second order condition, and find whether it is greater than 0. If it is greater than 0, here it is greater than 0, therefore AC is minimum at Q equal to 4.5. Then find the marginal cost, substitute the value of Q equal to 4.5 into the marginal cost function. Another important question is, given the total cost function TC equal to 1 by 10 q square plus 5q plus 200, obtain quantity produced when average cost is minimum. Here also we need to find the Q and the minimum of AC. Given the total cost function, this is an example. A homework is given here. Given the total cost function TC equal to 1 by 10 q square plus 5q plus 10, obtain the quantity produced when average cost is minimum. Here you need to find out the value of Q when average cost is minimum. Therefore, find the average cost. First find the average cost, then set the conditions for minimum, find out the value of Q, then check the second order condition. But if it is satisfied, the given or the derived output is produced at the minimum of AC. Another example is given here. The cost function is given as TC equal to Q into Q square minus 2. When output is 3 unit, find marginal cost. Total cost is given Q into Q square minus 2. Then we can expand this function as Q into Q square minus 2. Q into Q square minus 2 can be written as Q cube minus 2Q. Then marginal cost can be derived as dTc by dQ. That is, the first differential of the total cost function is the marginal cost. That is Q cube minus 2Q. Q cube, differential of Q cube is 3Q square. That is 3 into Q, 3 minus 1. That is 3Q square minus 2. Differential of 2Q is minus 2. Marginal cost when output Q equal to 3, equal to substitute Q equal to 3 into the marginal cost function. That is 3 into 3 square minus 2. 27 minus 2 is 25. Another question is, a company sells X units of the product each day at rupees 10. The total cost of manufacturing these things is rupees 6 per product plus a fixed daily overhead cost of 750. Determine the cost function, revenue function, profit function. What are the total cost, total revenue, total profit when 250 units are produced? What is the average cost when 10 units are produced? These are the questions. Here, the first part is company sells X units of the product each day at rupees 10. That is, the price of this product is 10. Then second part is the cost of manufacturing these units, X units is given as 6. That is, the per unit cost of producing X unit is rupees 6. Therefore, the variable cost is 6 into X plus the daily overhead fixed head is 750. That is, fixed cost is 750. Therefore, we can derive the total cost as variable cost plus fixed cost. Variable cost is 6 into X, 6X plus the fixed cost is 750. And the revenue function, second question is revenue. Revenue is total revenue. Total revenue equal to price into quantity. That is P into X. Here the price is given as 10. 10 into the total units produced is X. That is 10X is the total. It is the revenue function. Then profit function is TR minus TC is the profit. That is total revenue minus total cost is the profit. That is 10x minus 6x plus 50. That is 10x minus 650 minus 750 equal to 10x minus 6x 4x minus 750. That is the profit function is 4x. The profit function is 4x minus 750. When x equal to 250, fourth question is what are the total cost, total revenue and total profit when x equal to 250 units? This is the fourth question. Answer to this question is when x equal to 250, find total cost, revenue, total. That is substitute x equal to 250 into this equation. First one, total cost 6. Total cost function is 6x plus 750. That is 6 into 250 plus 750. That is 2250. Then total revenue function is 10x, 10 into 250. That is 2500. Profit is this, either we can find from this or we can apply from this profit function 4x minus 750. That is 4 into 250 minus 750 equal to 250. Then next question is what is the average cost when 10 units is produced? Average cost equal to total cost by x. Total cost is 6x plus 750 divided by x. That is 6x by x plus 750 by x. That equal to 6x by x is 6, 750 by x is 750 by x. 750 by x equal to 750 by x. Therefore, the average cost function is 6 plus 750 by x. Now substitute x equal to, that is 6 plus 750 by 10 equal to 81. This is the, therefore, here the question is total cost of producing x units is 6 units plus the fixed cost is 750. Then derive the cost function, revenue function, profit function. Then find the value of these functions when 250 units are produced. Find marginal average cost. Then average cost when 10 units are produced. These are the answer to solution to this question.